Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Nurul Smithis Nizam, S50838. And today I will present about speed controller in toys or PWM in DC motor. Here we go to the introduction. Small DC motors are suitable for use in applications such as small toys, models, robots, and other electronic circuits where speed control is required. The circular magnetic field generated by the windings of the armatures produced around the armature both north and south poles that are repelled or attracted by the permanent magnets of the stator, producing a rotational movement around the central axis of the motors. The simple and easy way to control the speed of the motor is to control the voltage across its terminus, and this can be achieved by using pulse width modulation or PWM. As its title implies, speed control of pulse width modulation works by driving the motor with a series of on-off pulse and varying the duty cycle. The fraction of time the output voltage is on compared to when it is off of the pulse while maintaining the constant frequency. By varying with the width of this applied pulse and thus varying the average DC voltage applied to the terminus of the motors, the power applied to the motor can be controlled. In other words, the wider the pulse width, the higher the average voltage applied to the terminus of the motor, the greater the magnetic flux within the windings of the armature, and the faster the motor will rotate, as shown in the figure. As can be seen on the slide, on the left side is about my flowchart. The flowchart indicates how the procedure has been achieved. In this project, when the motor is running, certain conditions will be applied. LED should be dim and the fan should be slower. And on the right side, it is about the coding program of the DC motor in toys. The coding was successful built in the MP lab. This is the condition of PIC SimLab before the RB3 is pressed. When the RB3 button is pressed, the fraction of time that the output voltage is on and the pulse of frequency is varying, as can be seen in the oscilloscope. Compared to when it is off, the pulse of frequency is constant. All LED in port D are off, while all LEDs in port B are on, but dim, except for B0 and B3, which not light up at all. The longer the pulse is on, the faster the motor will rotate, and likewise, the shorter the pulse is on, the slower the motor will rotate. If the controller is not on, this project should process from the start. LEDs and fans are always in on mode. The only difference are the LEDs light up brighter or dimmer, and the speed of the fan either faster or slower. But in my project, only LED are dimmer. The fan are not moving at all.